All right, so x equals 4, where we were. What would x equals 4 be? Well, instead of z equals 2, we got x equals 4, and so we're talking about a different place, but it is x equals a number, so that's going to be a plane. It's just that now the locked-in variable, if you will, is x, and so stands to reason here that we've got this, the level of it, or location of it, if you will, where that plane is it's out here. X equals 4, isn't it? And so it would be that plane out here at x equals 4. So instead of kind of being a flat floor kind of thing, or ceiling, it's out here at 4. And so we, if we were talking about x equals 0, you'd be out here at the YZ plane, but it's 4 units moved out, if you will. So here it comes, so it's just kind of that flat plane that goes through. Again, it's just hard to represent that, show that without some, I don't know, more skills, art skills. But you know what we're saying there. It's the plane that would be the XY plane, but it's 4 units away from the origin, 0, 0, 0. Okay. So, all right. Yeah, it'd be parallel to the YZ plane, but 4 units in front of it. Way to describe it. Sometimes I don't want you to describe it. Now, we'll graph some things, but you know we're limited into what we can graph. And we're certainly, computers can graph more things, but it helps for us to try to get our brains to recognize certain things. I guess is the idea. But let's jump to this. All right, so let's say we've got x squared plus y squared equals 9. And we've also got another part of it, z equals 2. So x squared plus y squared equals 9. And then z equals 2. And, you know, sometimes it does help you to start with, well, what would it look like in just 2 dimensions? All right, so x squared plus y squared equals 9. That's a circle, isn't it? A circle with radius 3. However, if we throw and as far as xy goes, the center would be 0, 0, right? X is 0, y is 0. However, we throw in the fact that z equals 2, what that does is it takes our circle that's y-axis, that's the z-axis, and then the x-axis here. So it's a circle in the xy plane. However, z equals 2, that tells me where it's located, right? Instead of being here in the xy plane circle, which, by the way, a circle, if we represent that circle in the xy plane, you got 3 units all around. And so it's not going to look like it, but it's kind of be elongated. So anyway, that's those sorts of things you got to kind of work out on your own. But this tells me the z, that would be if it was z equals 0. This says z equals 2, and so we're going to go up 2 units and put a circle there of radius 3, center 0, 0. So yeah, it gets a little tricky, especially if you're challenged to draw like I am. So, yeah, you got a circle, but it's raised up 2 units up. All right, now, why that's important, because we won't necessarily have that kind of restriction a lot of times where you have an equation, then you have just another part to it. I guess you could, but what if I just had x squared plus y squared equals 9 in r cubed? And so this doesn't have the restriction or the extra part that z equals 2. And so what that tells me, z can be anything. Z isn't locked in to be a specific number. I've still got the circle, radius 3, the xy circle, if you will, radius 3, center 0, 0. However, now z can be anything. All right, well, so that means, what does that mean? Oops. Well, let's just think about it, all right? So we've got the circle where z equals 0. So the circle z equals 0, that's the one I tried to draw here. Just radius 3 circle. So you got that one, that's when z equals 0. But we've also got them at z equals 1, and z equals 2, and z equals 3. Let's just put 1 up here at z equals 3. So we've got another same size circle. Trouble judging distances here. So you've got that same size circle, but at a level of 3. Well, okay, so we've got, and you've got 1 at 1, 1 at 2, but you've also got them between there, 1.5, 2.5. You see what I'm saying? So you've got all these circles in here. Then you've got some that are below the xy plane. So down here at, say, -3, I've got another circle. And then one's below that. So what happens is I get this, turns out I get this, it's 2. Kind of this infinite infinite 2 cylinder. Just kind of goes through, right through the middle here of our coordinate system. That's what I get, it's a cylinder. Infinite cylinder. Right? Makes sense? All right, so that's the sort of things you run into. You know, a lot of the equations will have x, y, and z when we're talking about 3 dimensions, but sometimes they won't. Sometimes they'll just be two variables. All right, let's try this one. Y squared plus z squared is less than or equal to 4. Well, we changed it now. We got the y and the z instead of the x and the y. Well, if you think about it though, y squared plus z squared equals 4. That's still just going to be a circle, isn't it? So you got a circle. It's just that the circle now, instead of being the xy plane, it's now going to be in the yz plane. And so you'll have have the circle in the yz plane. All right, so let's try to draw that. That's z, that's y, this is x. So if x is 0, we're talking about a circle in the yz plane that's It'd be radius 4, center 0, 0. Sorry, radius 2, square root of 4. So that's the one that would be in the YZ plane, or x equals 0 plane. Well, what's going to happen though? X can vary. X can be 1, 2, 3, or anything in between, anything greater, -1, -2. So you're going to have this circle, but at 1, and then a circle at x equals 2, and then a circle at x equals 3, so forth and so on. So yeah, you get this another circle out here. Let's say that one's at x equals 3. Then we'll have ones that go backwards. So let's do one at, say, -3. So you still get a cylinder, all right? Still get this. Infinite cylinder. However, now the tube is around the x-axis, I guess you might say. Now, what do you think the less than contributes to this? Well, we want points where you have x squared plus y squared is y squared plus z squared is less than 4. Where would that be? It'd be inside of it, yeah. So, whereas this one's a hollow cylinder, hollow tube, you throw in the less than or equal to, throw in the less than part, that's just going to solidify it. So it's all the points inside the tube as well. Okay? So, yeah. Get quite a bit of different stuff. All right, now, I guess while we're at it here, in R2, x squared plus y squared equals r squared, that's a circle. Now, when we go to R, the three-dimensional counterpart to the circle, so this is not what I would consider the three-dimensional counterpart. If I've got x cubed, x squared plus y squared plus z squared, equals r squared. X squared plus y squared plus z squared equals r squared. In R cubed, then, what do you think that is? That'd be a sphere, yeah. So if I add the z squared in, or have all three squared inside there, yeah, that would be a sphere, radius r. This one, since it's not shifted at all, be center 0, 0, 0. Centered up at 0, 0, 0. Well, I can shift these circles too, can't I? Here, if I shift the circles, x minus h squared plus y minus k squared equals r squared is how we usually write that. And so the center there is h comma k. Well, we can do the same thing with the three-dimensional sphere. If I have x minus h squared plus y minus k squared plus z minus L squared equals r squared, then that's also a sphere, but the center now is radius r. But the center is shifted. We shifted h in the x, k in the y, and then L in the z. So. So a sphere center 3, 4, -2. It goes through. -4 and 6, 5. Well, of course, this gives me my H, K, and L to that formula. So it'll be x minus 3 squared plus y minus 4 squared plus, so L is -2, so it'd be z plus 2, right? Do the opposite sign. The only thing missing here is I don't have the radius. I just have that it goes through another point. Well, remember the way we calculated then the radius is, this is an x, y, z that is in then the equation, or satisfies the equation. So I can plug those in for x, y, and z, right? So similar. A lot of these things that we do in 3 dimensions, we'll do the same thing as we did in the 2-dimensional counterpart, just more of it, I guess. That's it. So if we plug in the x to be -4, what does that make? -7 squared. Y is 6, that'd be 2 squared. And then 7 squared. That's what r squared is. 49 plus 4 plus 49. So that's r squared. Which radius would be the square root of that. What is that? 2. So the radius would be squared 102. But actually, r squared is what we needed. So the equation is x minus 3 squared plus y minus 4 squared. Z plus 2 squared. All right. And we got other similar problems that may have to review right there. Also good news is the distance in 3-dimensional. You got the distance between 2 points, x1, comma y1, comma z1, and then x2, y2, z2. Good news is that distance, we call this one P1 and this one P2, point 1 and point 2. So the distance between P1 and P2 is, it's good news is it's very similar to that distance in 2 dimensions. Just take the difference of the x's, square it, square that, difference of the y's and square that, and difference of the z's and square that. So again, just extend out the formula just a little bit.